right, so this is topic 3, day 12. And it's correlation versus causation. This is a hugely important concept for real life. Just being an educated person and knowing when you hear things, whether it's true or not. For example, did you guys hear like a couple years ago, this was like 5 years ago, where they said, oh, if you immunize your 5-year-old, you're going to give your child autism. Do you remember hearing about that? No? Well, it was a big thing. Parents like, oh my gosh, we're killing our children. So they thought, well, if I give my child a shot at 5, which is when they're supposed to have certain number of immunizations, it's going to cause them to have autism. And they pointed to statistics. They said, look, all these parents that immunized their kids got autism. And they said, see, there's the data. That's an example of correlation, where they found one set of data seemed to match another set of data. Where they messed up was on the causation. Just because two things line up doesn't mean that one causes the other. And scientists went back and they explained, no, it's just that at age 5, that's when autism appears in children. It's genetic. You're born with the gene, and it doesn't usually show itself until the kid's 4 or 5. The fact that they happen to be immunized when they're 4 or 5 is just dumb luck. But the two aren't related at all. So that's why, as an educated person, it's really important when you hear things to decide, is it correlation or is it causation? Because one is much different than the other. Okay, so correlation, let's start with that one, the definition. Correlation, and we did this definition yesterday, is the degree to which two or more quantities are associated. Like, how closely are they associated with each other? That's your correlation. All right, now causation. Causation is a relationship between two events. A relationship between two events in which one causes the other. A relationship between two events in which one causes the other. All right, we're going to draw a couple examples, and then I'm just going to show you some examples. So on your paper, I want you to draw 2 L-shaped graphs with about 1 inch in between them and 1 inch in the bottom. Okay, so the top one, on the bottom axis, it's the number of hours of exercise, and I'm assuming it's per week. And then on the y-axis, it's your resting heart rate in beats per minute. Resting heart rate in beats per minute. So, we're going to approximate this graph. So there's your scatter plot coming down. And in the middle on the X is about a 9. And in the middle on the Y, it goes up to 80. And of course, let's do a little best fit line right down through the middle of the data. This is a really high correlation. Actually, the data is a very high correlation. So it looks more like cucumber shape if you were to draw a circle around the points. If it's cucumber shape, that's a high correlation. So if we had to describe this correlation using vocabulary from our last lesson, this is a strong negative correlation. Strong because the data is very tight, looks a lot like a cucumber. Negative because the data is coming down. Okay, sometimes when they give you a graph like this, they have you describe the correlation, which we've done. You do that first. And then they want you to describe how one causes the other. So let's think about this. If you increase the number of hours of exercise, does it cause your resting heart rate to go down? Or does your heart rate dropping make you do more exercise? Which one is the causing factor, the one that causes the other? This is common sense. Don't be afraid. Does exercising more hours cause your heart rate, your resting heart rate to drop? Or does your heart rate dropping make you do more exercise? Yeah, the exercise, right? You exercise more, and then people that exercise more when they're at rest, their heart rate actually is lower than people that don't exercise as much. So that's the one that causes the other. It makes it happen. So your reasoning would be increasing hours of exercise gets you in shape. Increasing hours of exercise gets you in shape, which causes your resting heart rate to decrease. So the format for this is you want to use words like increasing and decreasing. Increasing one either increases the other or it decreases the other. You give the why. Why does it cause the other? That goes in the first part. In this case, increasing your hours of exercise gets you in shape. And that's why it causes your resting heart rate to decrease. So that is a causality statement. So they ask you for a causality statement. That's what they want you to write. Something is increasing or decreasing. This causes something to happen. So the other data increases or decreases. Okay, so let's do the second one. This is example 2. Okay, on the X, number of ounces of chocolate. On the Y, your happiness index. Index just means they took a survey and they measured your degree of happiness. All right, in this graph, kind of looks like a big exclamation point or a balloon. Looks about like that. All right, if you had to draw a best fit line, you would definitely go through the tail, through the middle of the bulby part. All right, so if you had to determine the strength of the correlation, if you had to draw a circle around the data, because of the bulby part, your circle would be more potato-shaped than cucumber-shaped. So potato-shaped is more weak than cucumber-shaped. So this is a weak correlation. The data is going up, so it's a weak positive correlation. It still has a pattern. You can see it's still a correlation. It's just, it's a really weak one. Okay, so that is your correlation statement. Now we're going to do your causation statement. So you got to think about it both ways. Does eating more chocolate make you happier? Or does becoming more happy make you eat more chocolate? It can. Here's the question, and this is what you got to think about. Does it automatically, almost always cause it? Does it automatically, almost always cause it? And the thing about eating chocolate is a lot of people eat chocolate just because they like chocolate. It has nothing to do with their happiness index. So eating chocolate does make some people happy. Other people, they just eat it because they like it. So the chocolate doesn't automatically always cause happiness. Some people eat chocolate when they're unhappy. So if it doesn't always happen or always cause it, there isn't any causality. So in this case, there's actually no causality for this. One does not cause the other. All right, I'm going to show you some graphs. And we're going to decide, is there, what type of correlation is it? And what type of causation is there, if anything? Okay, so here we go. We're going to look at a couple graphs. Here's the first one. This is your average quiz, your quiz average. So the average of all your quizzes and your final, I'm assuming final on the test. Okay, so, and I'm going to go one by one as we go through these. So you first, does this look like it has a weak correlation or a strong correlation? Weak. Good job, I agree. Is it a positive correlation or a negative correlation? Yes, this is a weak positive correlation. It is going up, but it's very, very wide. But it is going up. So does doing better on the quizzes mean you're going to do better on the final? Or if you did well on the final, it goes back and makes you do better on the quizzes? Yeah, one of them builds to the other because you take the final at the end of the semester. So the causation is that, yeah, if you do better all along on the quizzes, your final test will go up. It's not a for sure thing, but there is a pattern there that it will go up. So there is a weak causation there. All right. This one is what your car says about your salary. So down here is your salary. It's $50,000. That's $250,000. And then we have car prices, $20,000 up to $140,000. Holy cow, that's an expensive car. Okay. All right. So Aiden, is this a strong correlation or a weak correlation? Strong. Yes, definitely. Okay. Madeline, is this a positive correlation or a negative correlation? Yes, this is a strong positive correlation because it's going up. Now, the question is, though, causation. Does making more money automatically, almost always, mean you're going to buy a more expensive car? I want to see thumbs up if it's a yes, it causes you to buy a more expensive car, or thumbs down, it does not cause you to buy a more expensive car. Which one is it? Okay, there's actually quite a bit of variety out there. Okay, so let me ask you this. Can you make a lot of money and buy a cheap car? Yeah. Can you make a lot of money and buy an expensive car? Yeah. Does making a lot of money force you to do either one of those? No, no causation. It might be a correlation that people with more money do tend to have slightly more expensive cars, but that's not a causation. It just means that tends to go together. So that's the guy. You got to keep the difference between correlation and causation. All right, here's a great graph. This is the annual number of shark attacks, both fatal and non-fatal. And this is ice cream sales in thousands of dollars. So according to this graph, as the number of shark attacks increases, ice cream sales increase. Yes, I know, very in-depth there. Okay, Dela, is this a strong or weak correlation? It is. Elijah, is this a positive or negative correlation? Positive, yes, strong positive correlation. Very tight data. Now think about causation. Does the number of shark attacks cause people to eat more ice cream? So thumbs up, yes, shark attacks cause ice cream. Thumbs down, no, shark attacks does not cause ice cream. Let's see what you think. Thumbs up, thumbs down. Ah, good. Okay, we're all pretty much on the same page with this one. Yeah, no causation. Might be a pattern, but it's not there's no causation there. Here's a fun one. Heights of fathers in inches, heights of mothers in inches. So as the height of fathers is increasing, the height of the mothers is decreasing, except for one outlier. Okay, so Alex, is this ignoring the outlier, because right, we don't pay attention to the outlier. This is a tough one. Is this one strong or weak? What do you think? Cucumber or potato?
I think potato. Well, if we're ignoring that one, cucumber.
Yeah, it's this, if you draw it around, if you skip that one, it's cucumber shaped. Yep. So fairly strong, yes. And Kelvin, is it is it positive or negative? Correlation. Negative, yes, this is a negative, strong correlation, all right? So now we got to get into causation. The taller a guy is, causes you to marry shorter women. So does the height of the dad cause the height of the mother to be low? So thumbs up, yes, one causes the other. Thumbs down, no. Let's see what you think. Elijah, commit. Causation or not? Thumbs up, thumbs down.
Thumbs up.
You think one causes the other? Actually, this one doesn't have any causation. Your height does not determine who you marry. There might be a correlation where the data seems to match up, but there isn't causation. So you guys getting the idea that correlation is around a lot, but causation is not. Causation is way more difficult to prove. Now here's one. This one does have some causation in it. Hours spent studying, 1 through 10, score on the final exam. The more hours you spend studying, the higher your exam scores. This one has causation. The more you study, the better you know the material, the higher you score on the test. This one has causality. It has correlation also. This is a strong positive correlation, but it also has causation. And last one, I just thought this one was really funny. I found this graph. It's pairs of blue socks owned versus baskets made in the homecoming game. So how many pairs of blue socks you have versus how many baskets you made. Probably no correlation between your blue socks and how many baskets you make. But an interesting correlation. It's pretty tight data. So that's the biggest difference between correlation and causation. One of them is much more difficult to prove. There's lots of correlations out there. But the question is one causing the other? And that's why you have to be an educated listener when you hear data and studies. You have to really listen to it. Like the autism study that I mentioned. They took all this data, they freaked all these parents out because they said, well, at age 5, all these kids who were autistic were immunized. How many of you were immunized when you were a child? Like vast majority of you to get into school probably were immunized. Yeah, and yet what percentage, I'm not going to ask for hands raised, but what percentage of the class is autistic? According to that study, if you were immunized, you should have autism. Yeah, no causation on that. Correlation, yes. Causation, no. All right, that is the end.